All right, first of all, every muscle that we're going to study in lab, the skeletal muscles, are attached to bones. And they're attached to bones on two ends. So on one end, you have the origin. Now, where the muscle attached at the origin of the bone is the immovable end of muscle attachment. In other words, this part will never move. The insertion is the other end of the bone that the muscle is attached to. And this end is the movable end of muscle attachment. In other words, this one will move. So let's take a look at this example here. You have your biceps. So biceps here has two attachments on the top, right? It's attached to the scapula. So you might remember the coracoid process, which is the anterior process of the scapula. That's one point of attachment of the scapula. And the other point of attachment on the scapula is in the back. So these are both the origin. So now if you were to flex your biceps, take a look and see what's moving. Is your scapula moving at all? No. Again, because the scapula is the origin. It's the immovable end of the muscle attachment. Whereas that insertion, the insertion of your biceps is down here on the radius. And again, this is the bone that will move. So now if you flex your biceps again, notice your radius is moving. So importantly, you'll notice that the insertion always moves toward the origin. In this case, as you flex your biceps, the radius bone moves towards the scapula. So this is important to remember, this origin and insertion, because as you go through your list, you'll notice that most of the muscles do have an origin point and insertion point. So let's take a look at your muscle list since we'll be referring to it throughout the lecture. In fact, you should have your muscle list out with you as you go through this lecture. Right, so I've shown you the muscle list here in your lab manual on page, look here, 48 and 49. Now notice, with the exception of the face, all of the rest of the muscles, you'll see the muscle name here on the left column. You have the origin in the second column, the insertion in the third column, and then the action in the fourth. So again, the origin is the attachment to the bone that does not move. The insertion is the attachment to the bone that does move, and therefore the action, if you look at it, will help you move the insertion point toward the origin. So let's go down to biceps brachii, which we just looked at, and notice the origin, the scapula, the insertion is the radius. All right. Next, we're going to understand the concept of lever system. So this is the idea that your skeletal muscles are attached to your bones and help your bones move. So muscles move bones in what we call the lever system. So let me explain how this is going to work. First, in the lever system, you have a lever, which is a rigid bar on a fulcrum. So here are some examples of levers. So if this were the fulcrum, think of it as like the balancing point. And then these here would be the levers, the straight part of the scissors. Here's another example. Here's the fulcrum, again, which is like the balancing point. And then this right here would be the lever, the rigid bar. And then here's another example, a fulcrum, which is the balance point, and then the lever would be these rigid bars. Now, the fulcrum, as I was pointing out, is the fixed point for the lever, so the balancing point. So when it comes to talking about muscles and bones, the bones, of course, are the hard, rigid bars, so they're the levers. The fulcrum, which is the fixed point for the lever, those are your joints. So basically the bones are going to move around the joint, and that makes sense. For instance, your humerus is going to move around the shoulder joint with your scapula, or the femur is going to move around the hip joint with your pelvic girdle. Now, the important thing is that the muscles are involved in helping the bones move. So without the muscles, there's no way you could get these bones to move around the joint. And that's how the lever system works. So again, the muscles are attached to the bones, and then the bones move around the joints. All right, next we're going to talk about muscle actions and interactions. So we just talked about actions of muscles and how they move, and we know that the movement is produced at the joint. Importantly, muscles interact together, so you never really have just one muscle working by itself. So let's talk about these interactions. For example, let's use this concept again of flexing your biceps. And when you flex your biceps, your forearm moves. Your forearm's your radius and your ulna. So the main muscle that's helping us move the forearm when we flex is your biceps. So we call the biceps a prime mover, or the agonist. It's the muscle that's responsible for the main movement, in this case flexing the forearm. Now, when the biceps brachii flexes the forearm, you actually have a muscle that opposes this main movement, that will want to go in the opposite direction. For example, extend the forearm. And that muscle is called the antagonist. So in this case, the antagonist is your triceps. Full name is triceps brachii, which is on the other side of the humerus bone from the biceps brachii. In addition, you have synergists. So it turns out that biceps brachii is not the only muscle helping you flex your forearm. The synergist is another muscle that helps this agonist. For example, in this case, there's a muscle called brachialis. So brachialis is actually sandwiched between biceps and triceps, but brachialis works with your biceps brachii to help flex the forearm. So notice we have three muscles involved here. We have the prime mover, or the agonist, which is the biceps, responsible for the main movement of flexing the forearm. We have the synergist, which helps out the agonist. In this case, is brachialis, also helping biceps brachii flex the forearm. And then we have an antagonist that opposes this main movement. So in this case, we have the triceps brachii, which won't flex the forearm, but will do the opposite action, which is extend the forearm. Now, for those of you guys who like analogies and watch movies, you might think of this as, for instance, your favorite comic action flick. Let's say you've got Batman, and Batman's the agonist. He's the good guy doing the main movement, doing the main thing. Now, Batman, of course, has enemies, right? Such as the Joker and the Riddler. So these would be the antagonists. They're trying to oppose Batman. Now, does Batman work by himself? No. He, of course, has helpers such as Robin, and they would be the synergists. So this is exactly how muscles work. You've got a whole group of them working together, and then some working against. Now, let me show you on your muscle list how to figure out which muscles could be agonists, antagonists, and synergists, and this will help you study. Alright, so I pulled up the muscle list again, and again we're focusing on the biceps here. Now, notice over here we've got biceps brachii, brachialis, and brachioradialis. Now look at the action. They all do the exact same movement. They all flex the forearm. So whenever muscles do the same action, you can group them as synergists. So all three of these would be synergists working together. And then one of them would be the main mover. In this case, we know it's biceps. Now look at the action below it. It says extend the forearm. Now you might remember when we studied the joints that flexing and extending are opposite actions. So therefore, you look at here and you see the opposite action is extend, and you know that this would be the antagonist, which of course is triceps. So without even knowing these other muscles, we can look at some other groups of muscles and figure out antagonist versus agonist and synergist. So let's take a look at, for instance, your leg muscles, or muscles that move the leg. For instance, we have our quads. So quads are actually four muscles. Now go over here and look at the action, and you notice that it says extend the leg. They all extend the leg, so they all would be synergists. Now right below it, you see the opposite action, which is flex the leg. So any of these muscles over here, which are actually your hamstrings on the back side of your thigh, the hamstrings would be the antagonist to any of the quadricep muscles, again because they have the opposite action. And then of course, since all of the hamstrings flex the leg, these would be considered synergists. So this is just a way to look at your list and know automatically which muscles can be synergists and which muscles can be agonists versus antagonists. And again, notice where these muscles are located. They're often on the opposite side of the same bone. So your quads, for example, are on the anterior side of your femur, where the hamstrings are on the posterior side of your femur. Let's take a look at one more example. Notice over here in the action you see flex the thigh and extend the thigh. So you should automatically be thinking, okay, this is an agonist-antagonist pair. So these do the opposite. And you take a look over here, so iliacus and gluteus maximus are agonist-antagonist pairs. So whatever the action is that you're doing, that would be the agonist, and the other muscle would be the antagonist. one more thing before we move on. Certain synergists are considered fixators, and these would be synergists that help with the main movement, and they help so by stabilizing the bone. Alright, next I'm going to give you guys some pointers, and we'll go over this in lab 2. So when you look at your list, and you look at the names of muscles, a lot of times they're actually named very logically, and they're done by certain descriptions such as, for example, location. So if you take a look at your muscle list, you'll notice, for instance, in muscles of the face, you'll have a muscle, for instance, called temporalis. So location is often named after the bone that the muscle sits on top of. So just think about where you might find the temporalis muscle. Right, on the temporal bone. Same thing with frontalis and occipitalis. Where might you find those? On the frontal bone and occipital bone. It works also for other parts of your body. For example, you might guess that femoris would be on the femur bone, or tibialis anterior would be on the front of the tibia bone, or for example, fibularis would be near the fibula. So again, if you know your bones, the location of the bones will help you with some of the names of the muscle. Shape. An example of some muscle names come from the shape. For example, deltoid. Deltoid is a triangle shape, and you actually have an inverted triangle right over your shoulder, and that muscle is called your deltoid. Size. So muscles sometimes are named after their size. So for instance, you have fibularis longus because it's a very long in size. You might have gluteus maximus versus gluteus medius versus gluteus minimus. Those three different names are come from the size of it, maximus being the largest, minimus being the smallest. You also have, for instance, teres major versus teres minor, and from that you might guess which one's bigger, which is the major, and which one's smaller, which is minor. So you can just look at the muscles and look at which one's bigger and call that one the major. Direction. So muscles all have fibers, which are those cells, and they are very long, so they look like they go in a direction, or you see them as lines. So for example, you have transversus abdominis, and you might remember what transverse means. For instance, a transverse section, that means to go straight across. So transversus abdominis, if you look at the fibers or the lines on that muscle, they go straight across your abdomen. Or you have another abdominal muscle called obliques, and obliques mean diagonal. So if you look at these muscles, they go in a diagonal line, and this is exactly what you're working out. For instance, when you do sit-ups that are side to side, they say you're doing obliques. Another way to name muscles is by number of origin. So origins comes from how many origin points. For instance, biceps. Think about what bi means. 2. And we saw on the picture of bicep that it attaches to 2 different points on the scapula, so there's 2 origins. Think about triceps. Tri stands for 3, so your triceps has 3 points of origin. Or quadriceps. Quadriceps is actually 4 individual muscles, and each has their own origin point, so quad stands for 4. And then lastly, many muscles are named by the action that they do. For example, you have flexor muscles and extensor muscles all along your radius and ulna on your forearm. And the flexor muscles help flex your hand, and the extensor muscles help extend your hand. You also have adductor muscles in the thigh, and they help you adduct your leg, which remember means to bring it back in. So hopefully these naming hints will give you an idea on how to name the muscles and what they do.